Okay, so let's continue with our example here. So we have your trapezoid CALK, and we want to know the measurement of AL and CK. Okay, so we have here two sides AL and CK, and we're going to use the formula for finding the median of any type of trapezoid. So we'll already derive that formula. It's equal to the sum of the bases times bases of the trapezoid times 1/2. So it's going to be M. Okay, M is equal to 1/2 times base b sub 1 plus b sub 2. And from here, guys, we know the value of M. We can see here clearly on this illustration that M, the median, is equal to 89. Okay, so we can write that as 89. Okay, so using also the clues that we have here, we have 10x minus 2 as the first base, and 7x plus 39 as the second base. So we can solve for the value of x by using this formula. So let's try to do that. Okay, so we're going to have 89 is equal to 1/2 times base sub 1, which is 10x minus 2. And then we have to add that 2 plus 7x plus 39. Okay, so we can add those two numbers. So we're going to get 1/2 times, okay, 10x plus 7x, we're going to get 17x. And negative 2 plus 39, you're going to get positive 37. Okay, is equal to 89. And from here, we can distribute 1/2 to the terms. Okay, so we have here 89 is equal to 17 over 2x plus 37 all over 2. And therefore, we get that the value of x is equal to 89 minus 37 all over 2 is equal to 17 over 2x. Okay, and therefore, if we multiply both sides by the reciprocal of 17 over 2, which is 2 over 17, we get that the value of x is equal to 2 over 17 times 89 minus 37 over 2. Okay, and that is equal to, so x is equal to 141. Okay, 141 over 17, or if we transform that into a decimal, we're going to get 8.29. Okay, so 8.29 centimeters. Okay, so how about the measurement of AL and CK? So we simply substitute the values of AL and CK here. So let's just erase some of these parts. We've already solved for the value of x. Okay, so let's write here that AL. Okay, so AL is equal to 10x minus 2, so that's going to be 10 times 141 over 17. Okay, 141 over 17 minus 2, and CK is going to be equal to 7 times 141 over 17 plus 39. And therefore, the value of AL and CK in centimeters is equal to, so they're equal to 80.94 centimeters and 97.06 centimeters. Okay, so there you go. We've already solved for the value of x and the measurement of the sides for AL and CK for this isosceles trapezoid. So let's try this second problem. So given that we have here a mid-segment of AT, okay, so AT and AT measures 932 miles, okay, and we also have lengths VD and RO. We need to find these two segments, okay, VD and RO, and the length of segment VO, given the information that we have here. So if we notice, guys, we also have here the values for LV and HO. Okay, so LV, okay, so let's write that LV. Okay, so LV is equal to 400 miles. Now, since point A is the midpoint of LV, then we can say that line segment LA, okay, so line segment LA can be equal to 200, and also line segment AV can be also be equal to 200. And now for HT and TO, so we can divide 276 by 2 in order to get the measurement of HT and TO, since point T is the midpoint of HO. Okay, so we're going to get 138. Okay, so the values of HT and TO are 138. And from here, guys, we can use the Pythagorean theorem. Okay, so you can see here that we have your hypotenuse of 200 on this side, and we have your hypotenuse of 148 on this side. Okay, so we can solve for the value of VD by using the Pythagorean theorem. So we can have here the formula a squared plus b squared is equal to c squared. And then since we know that the value of the hypotenuse is equal to 200 and also to 138, we can write both of the equations here. Okay, so we can state that a squared plus b squared, since we know that the value of a is 97, so we can write here 97 squared plus b squared is equal to 200 squared. And also for the other side, we can write that since c is equal to 138, so that'll give you 138 squared is equal to 97 squared plus b squared. And now we can solve for the value of b. Okay, so this is going to be b squared is equal to 200 squared minus 97 squared, and b squared on the other side here is equal to 138 squared minus 97 squared. Okay, so let's try to solve for the value of b by taking the square root of both of these terms that we have for both equations, and therefore the value of b sub 1 or LH is equal to, okay, so LH, okay, I'm sorry, so VD, so VD line segment VD, or what do you call this, b sub 1. Okay, so since we're solving for the side measurement here, so it's equal to 174.90. so it's originally, okay, 174.90, so we can write that 174.9 miles, okay, for VD. And for RO, we have, okay, so RO, okay, RO is equal to 98.16. Okay, so that's the value of RO. And therefore, we can now get the value of VO. Okay, since VO is equal to VD plus DR plus RO. Okay, and since we know that the value of, okay, so this is solving for VO, okay. So we have here VD, okay, VD is equal to 174.9, the one that we solved a while ago. And dr is equal to 932 miles also, since this is a rectangle and its opposite sides are congruent. Okay, so we can write here that we have here plus 932, okay, plus 932, and then we have here RO. So RO is equal to 98.16. So therefore, the value of VO is equal to, okay, so it's equal to 1,205.06 miles. And therefore, we've now solved for the value of VO.